Imagine our Earth, but a very, very long time ago. 66 million years in the past, to be precise. This wasn't our world, it was a dinosaur's world. These magnificent creatures were everywhere. The mighty Tyrannosaurus rex with teeth as long as bananas was the king of the land. Huge, long-necked sauropods like Alamosaurus walked on 4 massive legs. They were so tall they could eat leaves from the tops of the trees. The planet belonged to them. They had been here for over 150 million years, an unimaginably long time. They were the masters of their domain, living under a warm tropical sun. The climate was much warmer than it is today. There were no ice caps at the north or south poles. The oceans were higher and shallow seas covered large parts of the continents. North America itself was split in two by a great inland sea. Jungles and lush forests stretched across the globe filled with strange and wonderful plants. Giant ferns grew alongside flowering trees. The air was thick and humid, filled with the buzzing of insects and the calls of strange ancient birds. It was a vibrant, thriving world, a symphony of life playing out on a planetary scale. It felt like a world that would last forever. On the ground, smaller dinosaurs scurried through the undergrowth hunting or hiding. Triceratops, with its 3 iconic horns and bony frill, moved in herds, browsing on low-lying plants. In the skies, giant flying reptiles called pterosaurs soared on leathery wings, some as large as small airplanes. The oceans were not safe either. They were home to giant marine reptiles like the mosasaurs, fearsome predators that could swallow a shark whole. This was the Cretaceous period. Life was big, it was dramatic, and it was everywhere. It was a perfectly balanced ecosystem that had worked for millions of years. But this ancient paradise was fragile. The dinosaurs, the pterosaurs, and the mosasaurs had no idea what was coming. They lived their lives day after day under a familiar sun. They had no telescopes to scan the heavens. They had no concept of space, of asteroids, or of the cosmic dangers that lurk in the dark. They were completely unaware that their world, and their long, successful reign, was about to come to a sudden and catastrophic end. A tiny speck of light in the distant sky was getting closer, and it carried with it the end of an era. How do we know what happened? We are detectives of time. Our clues are buried in the Earth itself. All around the world, scientists found something strange. It was a thin layer of rock, a dark line in the geological storybook of our planet. This layer marks the end of the Cretaceous period and the beginning of the Paleogene period. Scientists call it the KT boundary, or more recently, the KPG boundary. For many years nobody knew what this strange, thin layer meant. It was a mystery, a final chapter for the dinosaurs with no explanation. Then, in the 1980s, a team of scientists made a stunning discovery. They analyzed this dark layer of rock and found something that doesn't belong on Earth in large amounts. It was a metal called iridium. Iridium is very rare on the surface of our planet. Most of Earth's iridium sank to its core billions of years ago when the planet was still molten. But iridium is common in asteroids and comets. These are the leftover building blocks of our solar system. Finding a worldwide layer of iridium was like finding a cosmic fingerprint at the scene of a crime. It was a clue from space. The evidence pointed to a giant asteroid. An object from space had smashed into our planet. But if something that big hit the Earth, where was the crater? A crash that powerful should have left a massive scar. For years, scientists searched. The answer was hiding, buried under layers of rock and water. It was found off the coast of Mexico's Yucatan Peninsula. It is called the Chicxulub crater. The crater is enormous, more than 150 kilometers wide and 20 kilometers deep. It was the smoking gun. The puzzle pieces were finally coming together. We can now paint a picture of this cosmic messenger. It was an asteroid, a mountain of rock and metal traveling through space. It was about 10 kilometers across. Imagine something the size of Mount Everest. And it was moving incredibly fast, maybe 20 kilometers per second. That's dozens of times faster than a speeding bullet. For millions of years, it had been on a collision course with Earth. The dinosaurs, living their lives below, had no idea that their time was running out. The sky was about to deliver a final, devastating judgment. The day it arrived, the world changed in an instant. The asteroid, a brilliant point of light, grew larger and larger in the sky. It would have been brighter than the sun. It slammed into the shallow sea where the Yucatan Peninsula is today. The impact was more powerful than billions of atomic bombs exploding all at once. The energy released was unimaginable. The moment of impact sent a shockwave of unimaginable force across the planet. It was the single worst day in the history of life on Earth. The age of dinosaurs was over in a flash of light. The asteroid and the rocket hit were instantly vaporized. A colossal fireball, hundreds of kilometers wide, erupted into the atmosphere, pushing the air away to create a temporary hole into space. Trillions of tons of molten rock and debris were blasted upwards. As this material fell back to Earth, it heated the atmosphere until it glowed like the inside of an oven. The sky itself would have turned red hot. This intense heat would have cooked any living thing not sheltered underground or deep in the water. It started massive wildfires that burned across continents. The impact also created one of the largest tsunamis in Earth's history. A wave, perhaps hundreds of meters high, raced outwards from the impact site. It smashed into the coastlines of North and South America, traveling for thousands of kilometers and washing far inland. The sheer force of the impact also caused immense earthquakes, more powerful than any we have ever measured. Volcanoes all over the world may have erupted, as the planet's crust shuddered from the blow. For the creatures near the impact, death was instantaneous. For everyone else, the horror was just beginning. Imagine the sky. It was no longer blue. It was filled with soot from the global fires and dust from the pulverized rock of the crater. This thick, dark cloud spread across the entire planet, wrapping it in a blanket of darkness. The sun was blocked out. Not for a day or a week, but for months, maybe even years. This was the start of an impact winter. The world, once warm and tropical, grew cold and dark. The rules of life had been violently and completely rewritten in a single day. The world of the dinosaurs was gone, replaced by a nightmare. After the initial blast, the long-term effects began to take hold. The world was plunged into darkness. With the sun blocked by a thick shroud of dust and soot, photosynthesis stopped. Plants are the foundation of most ecosystems. They use sunlight to make food. Without sunlight, they withered and died on a global scale. First the small plants, then the giant forests. The planet's green lungs were shutting down. For the herbivores, the plant-eating dinosaurs, this was a death sentence. Their food was gone. Starvation was everywhere. The collapse of the plant world led directly to the collapse of the animal world. Once the herbivores died, the carnivores, the meat-eaters like Tyrannosaurus rex, had nothing left to hunt. The entire food chain fell apart from the bottom up. It didn't matter how big or strong you were. It didn't matter if you were the king of the dinosaurs. There was simply nothing to eat. This slow, grinding process of starvation claimed countless species. The impact winter also caused temperatures to drop dramatically, adding freezing cold to the darkness and hunger. Beyond the darkness and the cold, the very chemistry of the planet was changing. The asteroid had hit rocks rich in sulfur. The impact vaporized this sulfur and sent it into the atmosphere, where it mixed with water to form acid rain. This toxic rain fell for years, poisoning the soil and making the surface of the oceans more acidic. Many creatures in the sea, especially those with shells made of calcium carbonate, could not survive in these acidic waters. The devastation on land was matched by a catastrophe in the oceans. While the asteroid impact is the prime suspect, some scientists point to other troubles from that time. In India, massive volcanoes known as the Deccan Traps were erupting for thousands of years. They poured huge amounts of lava onto the surface and released gases that could have changed the climate. It's possible the dinosaurs were already struggling with this volcanic activity, but the evidence for the impact is overwhelming. The iridium layer and the Chicxulub crater tell a clear story. The volcanoes may have made things worse, but the asteroid delivered the final knockout blow. In the midst of all this destruction, not everything died. Some life survived. But the survivors were not the big, the strong, or the mighty. The winners of this planetary catastrophe were the small, the adaptable, and the lucky. Creatures that were small could hide more easily. They needed less food to survive, which was critical in a world where food was scarce. While the giant dinosaurs starved, smaller animals could get by on insects, roots, and the decaying remains of the dead. Being small for the first time in millions of years was a winning strategy. Among the survivors were our distant ancestors, the mammals. During the age of dinosaurs, mammals were mostly small, shy creatures. They were about the size of mice or shrews, and they were nocturnal, meaning they came out at night to avoid being eaten by dinosaurs. They lived in burrows underground. These burrows provided the perfect shelter from the heat of the impact and the cold of the impact winter. While the world above was burning and then freezing, these little mammals were safe in their subterranean homes, surviving on whatever they could find. Other creatures also made it through. Many birds, which are the direct descendants of a group of feathered dinosaurs, survived. Perhaps their beaks allowed them to eat seeds, which could lie dormant for years. Some reptiles, like turtles and crocodiles, lived in freshwater environments. These river and lake ecosystems might have recovered faster than land or ocean ecosystems. Insects, of course, proved to be incredibly resilient, as they often are. And in the plant world, ferns were among the first to grow back. Their spores, like seeds, could wait out the bad times. So why did they survive when the mighty dinosaurs didn't? It came down to a few key advantages. Living in burrows or in water offered protection. Being small meant you needed less food. Being a generalist, an animal that can eat many different things, was better than being a specialist that relies on one type of food. The dinosaurs were highly specialized for their warm, stable world. When that world vanished in an instant, they simply couldn't adapt fast enough. Their size and their success became their biggest weakness. The meek, it turned out, would inherit the earth. With the giants gone, the world was an empty stage. The KT event wiped the slate clean. For the small mammals that survived, this was the opportunity of a lifetime. Before the impact, dinosaurs filled every major ecological niche. They were the big predators, the big herbivores, and everything in between. Mammals were confined to the shadows. But now, the competition was gone. The world was quiet, waiting for new rulers, and our mammalian ancestors stepped out of their burrows and into the light of a new day. This new era is called the Cenozoic era, which means new life. It is also known as the Age of Mammals. With no dinosaurs to hunt them, mammals began to evolve and diversify at an incredible rate. They grew larger. They adapted to new diets and new environments. Some returned to the sea, evolving into whales and dolphins. Some took to the trees, becoming primates. Others became fearsome predators, taking the place of the T-Rex. The small, shrew-like creatures of the Cretaceous period gave rise to the amazing diversity of mammals we see today: elephants, lions, bats, and us. The study of this ancient apocalypse is a journey of scientific discovery. Paleontologists dig for fossils, uncovering the bones of the last dinosaurs and the first mammals to take their place. Geologists study the rock layers, reading the story of the impact in the iridium and shocked quartz. Astrophysicists model the impact, calculating the energy and the environmental effects. It's a cosmic detective story that brings together many different fields of science. Every new fossil and every new analysis of the Chicxulub crater gives us a clearer picture of this pivotal moment in Earth's history. This event is a powerful lesson in how life on Earth works. It shows us that life is not just about slow, gradual evolution. Sometimes, history is punctuated by sudden, catastrophic events. The KT event demonstrates the profound connection between our planet and the wider cosmos. Events in space can have dramatic and final consequences for life on Earth. Understanding this event helps us understand our own origins. Without that asteroid, the dinosaurs might still rule the world, and there would be no room for a species like ours to evolve. The story of the day that dinosaurs disappeared is more than just a tale of destruction. It is our story. It is a story about how a random event in the cosmos, a chance encounter with a piece of space rock, completely changed the course of evolution on our planet. The impact was a terrible, violent end for the dinosaurs, but it was also a spectacular beginning for the mammals. The same event that caused the greatest extinction of the last 100 million years also opened the door for our own existence. We are, in a very real sense, the children of the asteroid. This cosmic event teaches us a profound lesson about our place in the universe. Our planet is not an isolated island. It is part of a larger cosmic system. We drift through a solar system filled with leftover debris from its formation. The KT event is a stark reminder that what happens in space doesn't always stay in space. It's why scientists today track near-Earth asteroids. We now have the telescopes and the knowledge that the dinosaurs lacked. We can look up, we can see what's coming, and hopefully, we can do something about it. When you look up at the night sky, think about this story. The universe is not just a collection of beautiful twinkling lights. It is a dynamic and sometimes violent place. The same forces that create stars and planets can also destroy worlds. The history of life on Earth is deeply connected to this cosmic reality. We are the products of stardust, shaped by planetary processes, and given our chance by a cataclysm from the heavens. It's a humbling and awe-inspiring thought. The universe is woven into our very being. So, 66 million years after a mountain fell from the sky, here we are. A species capable of understanding the event that made our evolution possible. We can study the crater, analyze the iridium, and piece together the story of that terrible day. We are the legacy of the survivors, the descendants of those small, furry creatures that hid in the darkness and inherited a broken world. The end of one story was the beginning of another. And that story, the story of the age of mammals, led directly to us, a species that can now look back and tell the tale.